DesertRat stands for Desert Research and Technology Studies. This is a group of engineers and scientists.
We're looking to test out new concepts, procedures, equipment like rover concepts to see how they work in the field environment.
So the team tests these technologies to make sure that in future human spaceflight missions we'll be able to do science as best as we can.
A geologist from Goddard is going to be in each one of those rovers, myself and Jake Gleacher.
That's something that NASA's never done, two human rovers at the same time. So we're really trying to develop how do you use these assets at the same time, and interesting things that you might not think about are your communications. So you potentially have 4 astronauts talking all at the same time to a mission control or science communication background.
It's just like running a real mission, say, like you can think about the Apollo mission to the moon. You had the astronauts to the moon and you had the people mission control, but there was a science backroom you didn't hear about, but the astronauts were getting information from them.
Arizona has a very good climate for these types of analog studies. You have pretty much open plains and you have a lot of geological features that are analogous to places on the moon and on Mars. So in the morning we go through a briefing to make sure we know what we're doing for that day. And then the day is composed of executing that plan. So driving the rover from stop to stop. While we're driving we conduct geologic observations. We send that information back to the science backroom, and when we get to stops we actually get out of the rover and go on extravehicular activity, or EVA.
Those stations are typically on the order of about 40 minutes, and so like 40 minutes goes by very quick. When you get to a brand new area, first thing you have to do is describe the geology as concisely and in detail as possible for the people in the back room, and figure out where you're going to take your samples that you're going to collect. So you're figuring all this stuff out. But at the same time, you got to keep the status of all your systems. I mean, you've got this timeline that's running, and you're getting briefed on how much time you have left. You know, you got to move over here if you don't get this done, or if some equipment fails and you have to scrap the whole EVA, you get back in the rover and drive to the next station.
You get a lot of insight as to what a mission might actually be like. So for a scientist like me, I come in there and I provide my input as a field geologist. How does a field geologist use all that equipment? But it's fun to talk with your astronaut crew member because you spend a lot of time with them in the rover during your week-long mission. So you get to chat about what it's like to be an astronaut and hear their stories about the missions they've been on.
We have a lot of good people, hardworking scientists and engineers behind us, the scenes, and to make these things, be able to pull this off. So it's an honor and a privilege being a crew member.
And that's what it's really all about working for NASA, is testing new technologies, providing input back to the engineers to make sure that we build the best equipment so that when we do send people somewhere, they have the best of what NASA has to offer.